Dr. M. Rekha Devi, Assistant Professor in Physics, V.V. Vanniperumal College for Women, Virudhunagar. Today I am going to explain the most important topic in statistical mechanics, that is phase space and statistical ensemble. These two topics are very important in quantum mechanics also. First we have to see about the phase space. What is phase space? The phase space is the combination of momentum and position of the particles. That means molecule as a point in space, any translational motion of particle having the 6-dimensional in phase. That means 3 positional coordinates and 3 momentum coordinates. The position coordinates are x, y and z, and momentum coordinates are px, py and pz. These two combine to forming the phase space. Generally, phase space coordinates are the position and momenta of the all particles. Phase space can be rather complicated depending upon the particle dimensions. For 3-dimensional motion of a particle, the phase space is 6-dimensional. For 3-dimensional motion of particles in n particles, the phase space is 6n-dimensional. I will repeat this again. For a 3-dimensional motion of n particles, that means particles are including 3-dimensional motion of n particle, the phase space is 6n-dimensional. Every point in the phase space is in microstate condition. Next we have to see about the ensemble. Ensemble means that is a collection of identical particles is known as a system. An ensemble is a collection of macroscopically identical independent system. A system means collection of identical particles. An ensemble means collection of independent system. There are 3 types of ensembles are available: microcanonical ensemble, canonical ensemble and grand canonical ensemble. First we have to see about the microcanonical ensemble. Microcanonical ensemble means collection of large number of essentially independent system. That means the systems are independent in all the particles. There is a collection of large number of essentially independent system with same energy, volume and the number of particles. That is very important point in microcanonical ensemble. That is a collection of large number of essentially independent system. This system having the same energy and volume and the number of particles. The energy means E, the volume V and the number of particles is N. All the particles in microcanonical ensemble are identical. That means are in identical state means the system are in same state. The individual systems are separated by rigid, impermeable and well insulated walls. These are all microcanonical ensemble. The microcanonical ensemble, the most important point is it has same energy, volume and the number of particles N. There is no exchange of heat energy in microcanonical ensemble. That means there is no heat energy exchange inside the system. The values of E, V and N for a particular system are not affected by the presence of other system. Examples: gas atoms. This is the microcanonical ensemble diagram. That is the outside wall is the microcanonical ensemble. That is including in the reservoir. Reservoir means heat bath. The particle are including in the inside the microcanonical ensemble. There is no exchange of heat energy in microcanonical ensemble. Next we have to see about the canonical ensemble. Canonical ensemble means collection of large number of essentially independent system with same temperature, volume and number of particles. Collection of large number of essentially independent systems. The systems having the same temperature, volume and number of particles. All the particles are identical in canonical ensemble also. The individual systems in canonical ensemble are separated by rigid, impermeable but conducting walls. Microcanonical ensemble are separated by impermeable, well insulated walls but Canonical ensemble are separated by impermeable but conducting walls. Exchange of heat energy between the system takes place, but not the particles. Only the system can exchange energy, but the particles that does not exchange the heat energy. The most important point in canonical ensemble is the canonical ensemble having the same temperature, volume and number of particles. Exchange of heat energy between the system takes place, but not the particles. Example, salt crystal. This figure clearly shows the exchange of heat energy inside the heat bath. Next, we have to see about the grand canonical ensemble. Grand canonical ensemble means collection of large number of essentially independent systems with the same temperature, volume and chemical potential mu. All the particles are in identical state in grand canonical ensemble. The most important point in grand canonical ensemble is it has same temperature, volume and chemical potential mu. The individual systems are separated by rigid, permeable and conducting walls. Exchange of heat energy as well as the particles between the system takes place. Examples of grand canonical ensemble is biopolymers or proteins. This figure clearly shows the exchange of heat energy. Only the particles also. Del N is the number of particles, Q in is the input heat energy and then Q out is the outside heat energy. Thank you.